Hey everybody, Norm here. Here to talk to you about LabVIEW, the community training initiative, the Raspberry Pi Pico, and having some fun with potentiometers and servo motors and connecting them all together in a loop. As you saw just a moment ago, we've got the ability to take a potentiometer, hook it up to the Pi Pico, read a voltage off of that, and have LabVIEW translate that into a position that our potentiometer needs to be moving to. So it's not too bad, it's not too complicated, but it's a great platform for learning some of the fundamentals of LabVIEW for about as cheap as it gets. Once again, the Community Training Initiative is an external to NI, community-led initiative to create open source hardware, software, training, you name it, to make LabVIEW accessible to everyone, everywhere, for the least cost possible. So within what we've done here is I've got this Raspberry Pi Pico kit that I've mentioned in prior videos in the links below in terms of that hardware system. And then the other thing that I've done, let me see if I can get into it over here, is I've also purchased this Raspberry Pi Pico breadboard kit that is actually referenced in a lot of the Community Training Initiative documentation, different than the kit. This is really, really nice because it also comes with buttons that are already pre-soldered onto the board, LEDs that are already illuminated, and then also a piezoelectric buzzer, once again, already on this aluminum frame that makes it a lot more rigid. And then another also part that's kind of nice is that it already has pin headers for basically coming out to connect to each one of the I/O lines. You might barely be able to see them in there, identifying what their I/O, kind of on the silk screen for the printed circuit board, and also even the voltage rails and ground up top. So it's basically a cleaner way of getting started, albeit you don't get as much kind of out of the box as this kit, where that comes with a lot of features. You get some things, but you get a much more stable platform. So if you've got the extra bucks to be able to sink into getting this as an actual platform instead of using the open breadboard that we were looking at before, I'd say go ahead and move over to this. I'm going to probably be going back and forth whether it's a breadboard or not, but really at the core of it, if you're going to be using the Pi Pico, you're going to be running your experiments, go ahead and try to do something like this. So how did we get started, like kind of leveraging the setup that we've got here, and how could you follow along basically at home? So one of the things that is very, very important to kind of note out of all of this is that, let's kind of get some of these extra control things out of the way that are less important. Basically, I needed to reestablish my servo setup that I had before. So you can see basically I've got it in here, 3 wires going to basically positive and ground rail on the breadboard, and then this is going to basically channel 0, digital channel 0, going to that. So that just basically gets us back to ground 0, being able to control the servo like what we saw in the previous video. We're not going to re-review that. But what we needed to do, of course, is to be able to have this potentiometer act as a drive to an analog input. Now, the Pi Pico doesn't have like a resistance measurement capability out of it, right? The only thing that it has is an analog input, or well, digital as well, but for what we want is indeed it's an analog input. So somehow, some way, we needed to take a resistance, a changing resistance, and turn it into a changing voltage. And so basically what I did is create a very basic voltage divider network. You can probably barely see that resistor on there, going to the positive rail, and then it's going to pin 1. Actually, I could probably just pull it out of here, right? You can see we've got 3 pins on this. Let's see if I got, there we go. 3 pins on the potentiometer, basically one end of the resistor, other end of the resistor, and then a center tap that's fed from the screw, or fed from the feed of it. So I'm going to go ahead and get this plugged back in. And then basically, oh, actually, let's pull it back out while I've got it there. So I've got it basically going to, where's the pins? There we go. There's the pins. You can maybe, no, you can't even see them on there. Let's do that right there, something like that. And so we've got blue going over to our ground rail, so basically kind of completing the circuit. Blue goes to this side of it, the potentiometer, this one goes to the resistor, and then the brown wire here is our center tap feed. So let's go ahead and get that critter plugged back in there. All right, and then the other twist with this, the voltage that's going to be coming off of this one is we have to take it to an analog input. And whereas any of the digital lines, you can see it's like GP 0, 1, 2, 26, whatever, all over this Pico, there's only 4 very specific lines. Can you see 4? 4 very specific lines that are valid for looking at analog input. So let's go back to the main screen here and see if I can get that pulled up. I think I had it just a moment ago. Yeah, I did. And so you can see, this is usually what I look for. I look for kind of Raspberry Pi Pico pinout, usually for most of my things. And then you can see there's a lot of GPIO and a lot of extra things that we're going to leverage later, but only over here are the lanes that you can actually use for ADC. So GPIO 26, as it's noted on the silk screen on the board, or pin 31, if you've got a very specific pinout, is going to be ADC channel 0. And so let's go ahead and get that plugged in on the board over here. I'm going to go ahead and take that brown, plug it into GP26. There we go. And already my motor's starting to move and you can see it going. Now I've cheated because I've already done this video like 3 times already. So it's already working, but let's look at how we got it working on the actual program itself. So getting back over here to the main screen, I'm going to go ahead and back off here and you can see it's already going. So one of the things that I did is I looked at the previous programs that I had to try to figure out how to control it. Now, of course, if I run this here, this is already working. I think if I do this here, maybe you can see that as that changes, the servo, where are we at here? There's the servo, right? It's still doing its job, validating that that program works. That's always a good thing in engineering. Don't break the stuff you've already got functional. And then the other thing that I needed to do is I needed to read that analog input. And so from within the project, there is a read ADCs VI, and that's really the one that I started working with. And this is also where I figured out I was doing it wrong because I read channel 0, 1, and 2 going into the enable ADC, meaning general purpose 0, general purpose 1. So that was wrong for me. But indeed, I'm just going to go ahead and tap into channel 0. This is already something that's working. These are all very, very, very basic commands. And it's basically initialize, enable the channel, and then read the IO. And then of course the ADC value, if I were to just do this real quick, you'll see that as I change that IO, I'm going from 0 to, I think it's like 3150 or something like that, in between all those values. So all very simple, very easy. I'm changing the values. It's all working. So great. So I've got an analog input. I've got my PWM output. Now I need to merge those two functions together. How do you do that in LabVIEW? So I've got my programs that worked previously, right? They're still doing their job. They're still doing everything they need to do. But now I want to create a singular program. So something that you could do, once again, I'm going to try to teach you a lot of the little shortcuts. Control N makes you, basically gives you a brand new VI. But some of the things that people will do, and indeed quick drop shortcuts are very, very useful, per control space that brings that up. But the reality is we already have a palette of all the functions that we need to do the job basically on the other block diagram. So let's just go ahead and, rob from Peter to pay Paul. Let's just one for one, just kind of copy these functions over. Don't forget the Boolean on the enable. On a previous take of this video, it took me a lot of effort to try to remember to enable that digital output. Now I'm not going to wire them just yet. So if you're following along at home, go ahead and don't quite do all the wiring just yet. But we're going to go ahead and I think the duty cycle controls it, the frequency indeed goes ahead and gets it there. Let me go ahead and put those certain things in there. So that's all that we would need for controlling the PWM. And then let's go ahead and look at the ADC. Very similarly, so very simplistic diagram. I just need to enable that given channel. And then also I'm going to go ahead and read from the channel. Now, of course, I'm going to write I think it was was it the duty cycle? Yeah, the duty cycle. Let's find out let's go over here. Yeah, the duty cycle is the one that actually drives the position. So I'm going to put that over after the read. And here's a really nice feature in LabVIEW. Once again, every wire is a variable that you didn't have to create a name for. So if you select all of those functions, press Control Space, and then Control Shift W, really neat thing happens. It automatically wires up all of those functions, ins to outs, errors, and so on, type propagation, so many nice things happening there. And then the other part, what I'm going to do is I'm going to go ahead and another nice little shortcut is I'm going to create a constant for the frequency, because I'm pretty sure that frequency basically needed to be set at 50. So let's go ahead and put that value of 50 in there. But then if you're wiring or if you want a constant, so once again, I'm going to start the process of, let me see if I can do just monitor. There you go. So I'm going to start the process of wiring off of that, hold down Control and double click, and it's going to go to channel 0. Once again, that's channel 0 for the digital, which is the same as what we need over there. I'm going to go ahead and clean this up a little bit. Clean diagrams are happy diagrams. If you don't like the idea of cleaning up diagrams, just think about it at like giving variables good names. A clean diagram speaks just like good variable names speak. So same thing in terms of the reading for the channel of the digital over there. And then this is all analog, which interestingly enough is also going to be channel 0 for the digital. This is not the best way or the only way to go about doing this, but all right, so now we've got, I'm setting the frequency, I'm enabling channel 0 analog, I'm going to read channel 0 analog, and then basically I need to apply the duty cycle to it as well. I'm pretty sure this is all that we need. If we wanted to give an initial position to the pulse width modulation, we could kind of repeat this. Actually, that's a really neat feature. Let me go ahead and do that. So I'm going to find the name of this because you can only kind of do the insert easily. There we go. So this is a set PWM duty. So if I select these wires and control space quick drop, let me go ahead and get this out of the way there. And I type in set PWM duty. And if I hold down and I hit control shift I, it will insert a function on those wires, which is a really, really nice function. And then I'm going to go ahead and once again wire it up to the appropriate channel of interest. And then I'm also going to go ahead and give it another constant, but I'm going to give it the constant based off of maybe what I see on the front panel here for like an intermediate value. So there you go. There's my value. I'm going to put that in there. Great. So now when my program starts up, it's going to automatically position it to a default location overall. Let's go ahead and get, there we go. And so now what I really need to do is I want to be able to read and then write over and over again, which basically means I need to be putting a loop around that. So let's just go ahead and do that exact thing. So I'm going to go while WS for while structure, drop that around there. I'm going to go ahead and do that same twist where I'm going to double click while the wiring and it makes a control, not a constant. Only a constant if you hold down the control key. It's kind of funny there. I'm going to drop an OR statement on the wire here as well. Then I'm going to wire in the error. So what that means is it will terminate if there's an error or somebody hits the stop button. And then another neat feature that's been around in LabVIEW for a long time is a thing called the switcheroo tool, where if once again over a terminal, you might be able to see it here. When I press the control key, you can see that cursor kind of change. It's going to swap the terminals on that, once again, keeping my diagram a little bit cleaner. And then lastly, I'm going to go ahead and wire this to the output, and if there is an error, I'm going to be able to see what it is. So let's go ahead, and we're missing one other thing. I need to wire that duty cycle. Well, another thing that I'd had in the other program, once again, referencing prior art is always good, is I had this magic that went from, hey, when I go from 0 to 1, turn this into an appropriate duty cycle for my device at large. So I'm basically going to take that function, throw it in here. I'm going to wire that in, but there's also one other problem. This output is not going from 0 to 1. I need to normalize it. So I'm going to go through and put in a divide, add that into the system. I'm going to put that maximum value as an output here, which is like maybe like 3200. That should be probably adequate. All right, so if all goes according to plan, I'm going to go ahead and be bold in this case. I'm going to go switch over to the larger view. Let me see if I can do the split. There we go. And let's go ahead and I'm going to steal a control from, once again, another front panel that you saw earlier. Put that there. I'm going to wire that to the output of my ADC. And then also, let's go ahead and take, where's that other input here? I'm going to take that duty cycle and actually create it as an indicator of what we're driving into. Oh, not there. Of what we're driving into it, kind of as a debug mechanism. I could use probes in LabVIEW, also handy. But let's go ahead and do that. And I'm going to right click on that and turn it into change it to an indicator from a control from where it was. Wire that in. And so now we're going to get a little bit of feedback as we go. So keep your fingers crossed. Let's see what we get once we start to run this. Let's see if I can get this positioned a little bit easier. Let's see. Got that there? Nope. Everything's hanging off the screen. There we go. All right, let's see what happens when I go ahead and run this chunk of code. Oh, it moved it to a position, and ha-ha! There we go. Success. So I can't guarantee it's to its maximum values or its minimum values, but definitely I am controlling that. I've linked an analog input to an analog output in a very simple way. There's a lot of limitations on this, like, hey, how fast do you want to control the output? You can kind of tell if I leave it stationary, I'm not touching anything, it's got a little bit of flicker to it, so there's a little bit of noise. So I might want to filter that information, but you can see it's pretty darn responsive. You know, maybe it's not quite as fast as I can move it, there's a little bit of delay, but it's definitely doing the job at large. All right, so let's put a pin in this one. We've been going for a little bit, appreciate the attention. So we reproduced what we had before with the pulse width modulated servo control. Great, that's functional. We realized that we don't have an ohm meter on our Pi Pico. We have an analog input that reads the voltage. So we use the resistive network to create a very simple variable voltage with the limit regulating resistor in there to go ahead and kind of do the job. And lastly, we've got, oh geez, I don't even know if I looked through that. Well, in any case, yeah, and then we fed that into one of the explicit analog input channels and then used the LabVIEW API to just be very quick on the control. There's a lot of different ways if you were making a full-blown application, if you had a bunch of these in parallel, and if you couldn't read them and write them at the same rate, a lot of design changes would be required. But for simple experiments, getting started, and also just learning LabVIEW, once again, I still have fun. I've wasted so much time in the studio today just moving that potentiometer back and forth, just watching the motor move. It never gets old for me. Maybe I'm weird, but hopefully you are too in the right ways. So once again, get started with LabVIEW, get started with the community training initiative, leverage the Pi Pico and what it can do. And yeah, hopefully we'll see you back in the next sessions. Thanks.